Okay, now let's look at the terminology of a quadratic function. Let's look at what explain. A cannot become 0. Why? Because if A goes to 0, the function becomes Px plus C, and D is actually a linear function. Okay, if it's a linear function, then it is actually a straight line. Okay, a linear function will be a straight line. Okay, so it will not become a quadratic function if A is equal to 0. B and C can become 0, but not A. Okay. Now let's look at the second point that mentioned here. The point where the turn is called the vertex. What is the meaning here? Turn. Okay. Now, if you draw a line on this part here, the gradient of this line is actually negative. Okay, if we draw another line here, the gradient is still negative. Okay, until when he reached the lowest point, if you draw a line, a tangent, what I mean is tangent, it become at this point here, it become a straight line, a horizontal line at the lowest point. At this point, the gradient is actually equal to 0. Okay, now, then if we draw a line in this direction on this part of the curve, you notice that is always positive. Okay, so the point where the graph turns basically is referring to the change in the gradient from a negative. If we go in this direction, it's from negative becomes 0. The gradient, negative gradient. By the time it reaches lowest point, the gradient becomes 0. Why? Because the horizontal line for the tangent. Then the gradient of the tangent along here become positive. Okay. So this is according to this statement here, the point where is called the vertex. But actually there's other term used. They call it the turning point. Okay, the turning point. Called turning point. So now, if you look carefully at this, the lower points of y for this whole quadratic function happen at this point here. Okay, that's the lowest you can go for the y value. So this is the minimum turning point. Okay, we say that is concave upward. I mean this shape here. Okay, concave upward. Now, if the graph open downwards, what is it referring to? Open downward means this way. What is referring to? As you go further down, the point, the distance between the two parts of the curve become wider and wider. We open up as it go downward. For this case, we call it the maximum turning point at this point here. Okay, where the tangent of the gradient of tangent is equal to 0. This is called concave downwards. Okay. Now, let's look at the next point. You see that the vertical line that passes through the vertex is called the axis of symmetry. I mean this vertical line, it passes through the vertex or pass through the turning point. This is the axis of symmetry. Okay? It must be a vertical line. Remember, it has to be this axis is a vertical line. Okay? we call it axis symmetry. Parabola basically is talking about the shape here. Here there's a statement about parabola shape here. Okay. Each parabola is symmetrical about its axis of symmetry. That means to say this one could flip over exactly over here. Okay. And this axis here form the axis of symmetry. Then another point, the point where the graph passes through the y-axis is called the y-intercept. So where's the y-axis? This is the y-axis. The curve actually, the graph actually passes through at this point where it intersects with the y-axis. Okay, this point is called the y-intercept. Okay, intercept. Now, the point where the graph crosses the x-axis are called the x-intercept. This graph actually passes through here. It intersects with the x-axis is called the x-intercept. Similarly, this part of the graph actually intersects with the x-axis at this point. So, in other words, there are two x-intercepts. Okay. Let's look at this statement here. If they exist, okay, what it means is the graph intersect with the x-axis. If we intersect with the x-axis, then there will be x-intercept. Okay, like for example, this case here, there's two x-intercept. But then there are cases whereby what happens? If your graph is only up to here, okay, so it doesn't intersect with the x-axis. It means there's no x-intercept for this quadratic function. Okay, now this one got 2 points. This one 2 intersect. This one don't have any intercept. And then you have the case where it's in between. In between means it doesn't have 2 intercept, but it have 1 intercept. For example, okay. So in this case, the graph actually intersect with the x-axis at 1 point. 2 points of x-intercept. This one, no intercept at all. Okay. Now, the next thing we want to look at is they correspond to the root of the equation y equals 0. Basically, what it's saying is, if you want to find the x-intercept for a function, for example, this one, if I want to find the x-intercept for this, for x-intercept, we look at the x-intercept. What is the y value of the x-axis? Okay. Any point here, you notice this point here, the y value is always 0. Similarly, at this point here, the y value is 0. So what you have to find is this x1 intercept, the first intercept, x2 is the second intercept. Okay, what it's saying is when I make y equal to 0, so you have a case of 0 equal to a x2 plus bx plus c. When you factorize this and you get, they give you x1 and x2. Okay, the x1 when y equal to 0, this x1, x2 from after factorizing. This is called the root of this equation. Okay, when y equal to 0, and if this x1 will be here, the x2 will be here. Okay, hopefully you gain some information from here.